I talk to you in the next 10 minutes. I have very few slides about my work of 6 years, but I'm also going to talk to you about religion and about our addiction to our own bodies and how it reflects on this work. And I'm going to start with telling you stories about 3 things that inspired me to do this work. One of them is this particular picture. It's a picture of Israel where I was raised. And it's a picture of a particular city in Israel called Haifa. It's up in the north of Israel. And that's where the annual Israeli marathon is being held. So people run this marathon during the summer in Israel. It's very warm. And what they do is they basically launch 3 waves. So at 8 a.m., they launch the waves of the people who actually compete in the marathon for record. They leave at 8 a.m. Then about 20 minutes later, they release the people that are basically disabled. So there's another marathon for disabled people, and they go 20 minutes later, and they still compete for record. And then about half an hour later, everyone else gets to run. The people like you and me who are doing just for fun. And what happened in 2005, just about when I was about to leave Israel to go to Caltech to get my PhD here, the marathon was held, and there was a guy who was in a wheelchair, who basically was launched 20 minutes later, who won the paraplegic or the disabled competition, but he also won the abled competition. Basically, he went farther and he got first in both competitions. He was the first to arrive in the end line. And he asked to get the medal for both. He said, I won both. I actually had I was released 20 minutes later, and 20 minutes later, and I still won. I won the medals in both, abled and disabled. And they were kind of debating, trying to figure out what's going on. And then they realized that the map, the topology of Haifa looks like this. So basically, it's all downhill. So he basically released his handbrake and went down and won the competition. And they said, no, you can't get the medal because you had an advantage. It's unfair. You have wheels. And that's the first time where I kind of started thinking that in a way, what we call being disabled might be an advantage to some people. And we always have this kind of viewpoint that a person with a wheelchair is kind of unable to do something that we can do. And that's when I started thinking about this project. What you see on the bottom left bottom right is a picture of the typewriter. I'm sure some of you might know that. I don't think I see many people that are in the age range that they use that, but at some point people used to use that. And this was invented in typewriter in the year 1808. It was patented by an Italian guy, and he invented it for his friend, Countess, I forget, who was blind. And he patented this device saying it's a machine to help the blind write. There's not going to be any problem with handwriting. They can actually learn just kind of the morphology of this thing, and they can type. And this was a great invention that quickly was adopted by anyone to write. Everyone just used it, and it became the standard for writing. In fact, I have a person that I listened to who said that this is the ultimate laptop. It's a laptop with a printer that prints while you write. That's how crazy it is. And this also was an invention that came as something to help a disabled person. She couldn't write, and it became the kind of gold standard of what we use. And the third person is Miley Cyrus, an actress. And what you see here is a picture of her. That's a before and after. Apparently, she had a little bit of a change to her teeth. She went to a teeth organizer, and basically they removed her front teeth and put new ones instead. And when I talked to my dad once, and he has a little crooked test in the front, and he went to his dentist who just said, you know, you can actually get a replacement. You can remove your teeth, put a porcelain one that's going to be straight instead. And my dad was shocked. He said, what do you mean? I'm going to remove my teeth and put a plastic one, a porcelain one? That's my own teeth. And that's the religion part that I'm going to talk to you about. The fact that we actually see our body as something that is ours, we don't want to change much, and we kind of think of it as something that is very, very strongly attached to us. We don't want to start replacing parts of our body. And in fact, in the 1950s, there was a kind of a shift towards starting to change. The plastic surgery came first as something that was supposed to help burn people or people who had plastic deficiencies, and gradually became something that everyone wants. I actually heard that in Israel, this is the #1 request for bat mitzvah. 12-year-old girls asked to have plastic surgery. So it was something that started as a very, very, very kind of a thing that you do only if you need something very crucial for health, and became the gold standard. Okay. So here's 3 people that made what I'm going to talk to you into a reality. On the left, on the right, sorry, there's a runner called Oscar Pistorius. And if you've never heard of him, he's a South African runner who I became aware of when he actually appealed to the Chinese Olympics to run. So he is known as the fastest man on no legs, or Blade Runner is another way to call him. And looks like that. He has stints instead of legs. He lost his legs when he was 9 months old, and he basically could not use them, but he still became a very, very successful athlete. And he became such successful that in 2008, he asked to compete in the able bodies runner competitions in China, and he was not allowed because the claim was that he has some kind of advantage. He can run faster than most people and he shouldn't be competing in a competition. And he appealed and he actually won, but didn't qualify eventually because in South Africa he was number 3 and he didn't get to run. But in theory, this was the first case where a guy said, I want to compete with the rest of you because my legs, the prosthetic legs, are actually giving me advantage that it should not hinder my ability to play with you guys. The man in the center is Hugh Hare. He's a professor at MIT, but also a former, very successful mountain climber. He climbed a lot of mountains. He was a very successful American story, and he lost his 2 legs when at one point when he was 18, he was caught in Mount Washington on a summit trying to climb, and him and his 2 partners were basically stranded there for 3 days in minus 20 degrees Fahrenheit and basically lost the ability to move their legs. One of them died in an avalanche, the other lost his toes, and he lost both legs. He still climbs mountains nowadays with his 2 legs, and he is kind of a pioneer in this field of building all kinds of prosthetics that help people function in society regularly. And this is Amy Mullins, whose story I like the most, because she's a model who, again, at the age of 11 months, lost her legs for a fiber problem, and she replaces her legs commonly. She basically, as a model, gets different legs, different prosthetics every day, and she uses them. And one of the kind of nice stories that she tells is about her going back to high school to see her friends in high school in a school reunion, and she wore the legs that she liked the most, that make her look really beautiful. And she came to her friend in school, and the friend said, hey, you look taller. I remember you as a shorter girl. And she said, yeah, I actually wore my tallest long leg. And the girl said, this is so unfair. Which is the first kind of hint that we're starting to see more and more people that have some advantages that we need to get used to. So here's what I did this work. My work has to do with helping people move those prosthetics using brain signals. So I'm a scientist at Caltech here, and I work with 2 professors, one here and one at UCLA. And we're basically working on building machines that will be operated by brain signals. So here's just a graph that shows you the need for that. There's more and more people, that's just the US. There's more and more people in the world, and especially in the US, that require help in moving prosthetics, regaining the ability to move on legs. And we're trying to kind of find ways to help these people operate their own body using their own mind. So basically, if you think of it, there may be a little problem that made your brain not communicate with your hands, and now we can, if we can just bridge this thing, we can help people regain the control. So here's how it's done in the last 5 years. Those are 2 examples from 2 groups that work very closely to us, that work with monkeys. And what they do with monkeys is they basically put electrodes, microelectrodes, in their brains, recording activities of neurons in the brain, particularly in the motor area of the brain. And what they do is they help the monkeys learn quickly how to think about moving their hands or moving a joystick in that example, and learn how to operate a robotic arm outside of the body. So the monkey thinks about moving left. The brain machine interprets this, or reads this activity and figures out the monkey wants to go left and moves the hand. And you see on the right work by Andy Schwartz, who is kind of a pioneer of this field, where he had a monkey learn how to quickly feed itself. So the monkey sits there, you can see here, thinks about moving his hand right or left, and the robotic arm moves, picks the marshmallow, and eats it.
How does the monkey feel about it?
Oh, a great question. So here's my next slide. And this is just a work of Miguel Nicolelis, sorry, who also did the same thing. He operated the monkey. He did even something further. He actually operated the monkey in the US, in Duke University, and the robotic arm was actually in Japan. So he did something even further. The monkey sits in front of a computer, sees some things, moves his hand, and learns to operate a robotic arm far away, which is something that the army, at least, can use to have people sit in a little kind of chamber downstairs, move their hands, and control the airplane far away. What's interesting, to your question, Ben, is the following. What Andy says that's remarkable is the monkey first has his hand tied, and he kind of gives the instruction, move the hand right or left, and the robotic arm moves right or left, and he thinks about moving. He tries to move his own hand, but instead the robotic arm moves, and he gradually learns how to move the hand and feed itself. What happens very quickly, after a couple of hundreds of trials, the monkey gets tired of trying to move his own hands. He learned that he can't move his head. This is tied, and what he can only activate is the robotic arm. And what happens a step further is he stops trying to even move his hand. He just thinks about that and moves the robotic arm. And in a follow day, he learns to move his hand while moving the arm. So the brain actually learned to control a third hand. Now there's the hand that the monkey used to use with his brain. Now this one is activated by the robot, and the monkey can actually scratch his head while eating the marshmallow with his feather. And that's the remarkable moment. This is the plasticity of the brain that we can learn very quickly. If we lose the ability to do one thing, we can learn to regain it with something else. So here's to our work. In the past 6 years, what I've been doing is working on humans. So we're working with a unique collaboration with a neurosurgeon, Dr. Itzhak Fried at UCLA, who operates on patients undergoing brain surgery for clinical reasons. So the patients come because they have epilepsy, and part of the procedure to treat epilepsy is drilling holes in the brain, putting electrodes deep inside their brain, and waiting the patients to have seizures. The patient sits there and waits to have seizures so doctors can monitor the flow of the seizure in the brain and see where it originates and take it out so the patient can walk away seizure-free. At the same time, we have a patient sitting there in bed waiting to have seizures and not doing much with electrodes deep inside his brain. So the first patient to do that was actually in Brown University by a group that showed that this person can actually use this machine to control a computer game. And you see that while he's doing very well in activating a machine, changing channels, writing and reading text, it's kind of jerky, right? It's like he wants to move left and the cursor moves kind of in way to the right, but he can learn quickly to operate and close and open hands and move and pick up a glass. So this patient, who was the first patient to have done it, he actually died a year ago, sadly, but he had this machine, this device in his brain for 9 months, sorry. He was stabbed, and that's how he lost his ability to communicate with his body, and he was tetraplegic. But he learned quickly to change the channels, move his wheelchair, and pick stuff in the environment. And what we did was a work that was published just a few months ago. We used Dr. Fried's patients to implant electrodes inside their brain, ran a short, this is kind of how the setup looks. The patient sits in bed with wires in his brain waiting to have seizures. And we start by showing him a bunch of pictures of all kinds of things we think might exist in his memory based on an interview with him. So he says, I really like to watch the movie with Halle Berry. I've been to Paris last month. I'm afraid of spiders, and I voted for the Democrats. We show him pictures of those things, trying to find memories in his brain that encode those things. And this, I can go in length if you ask me a question about it, but it works very well. We find within very few minutes cells in the patient's brain that are activated when he thinks of those concepts. And what we did next with this patient, for instance, this example is a cell that encodes the memory of Halle Berry. When the patient thinks of Halle Berry, there's a firing of one particular cell. And what we did with these patients is we hooked them through the machine all the way to a decoder that we had on a different laptop that basically decodes in real time the patient's thoughts. The patient thinks of Halle Berry or of Marilyn Monroe or of an actor that he likes, Josh Brolin. We can decode in real time the activity of the patient in the patient's brain. We can know what he's thinking of in real time. And what we do with that is we build something we call the thoughts projector. The patient thinks of something and we show it on the screen in front of his eyes and ask him, is that what you thought? He said yes, and we kind of improve our decoder so the patient can think of one of a few things, and we show movies on the screen of his thoughts. And here is a bit of how it looks. It was published just a month ago in the journal Nature. It's called Online Voluntary Control of Human Temporal Lobe Neurons. The patient sits in bed. We start by showing them pictures to learn how the brain looks when they think of those pictures. Here's an example of a cell in the brain that fires. The patient sees a picture of Marilyn Monroe. Here's another cell in the same patient, different part of the brain, a cell that fires for the actor Josh Brolin. She liked him because he was in the movie The Goonies. And here's the experiment we actually did with the patient. We told her, we're going to show you one of the two images. We're going to put a picture of the two of them combined. I want you to think of that picture and move the images on the screen with your thought. So she sees the target as, in this case, I think Josh Brolin or Marilyn Monroe. This time it's Josh Brolin. She has to think of him, and by thinking of him, move the images on the screen towards him. And this she's going to fail, I think, in this trial. And then she gets better and better with time. And you see nicely how the competition happens in your brain, like how basically the patient has to do very little. She just has to sit there and think. But at the same time, it's exhausting. You see the patients getting sweaty. They're really focusing on their thought. They really work hard to just move their brain cells. That's all they have to do. So I can tell you if you ask me later about what happens there. It's very interesting to see what the patient does to do those things, how he quickly moves the environment, what he learns about that. But just kind of to give you the bottom line, our patients, we had 12 patients do this study, all did perfectly well. They learned very quickly after a few failures how to control images using their mind. They could be given any image we wanted out of a small sample that we chose in advance and just start thinking and move the images on the screen. And they all did fairly well. You see it here. That's how unlikely it is. And to end, I'm just going to give you kind of my spiel of this talk. And that is that while we are very religious about our body, gradually, I believe that we're going to start seeing people actually improving their body more and more by taking more, not just plastic surgery, but more and more advances, like maybe adding additional hand, additional finger to the things. And you can think of all kinds of new innovations for brain-machine interfaces. For instance, you know, if I'm going to go to New York tomorrow, and I want to know what the weather is like, I'm just going to go online and look at the weather, and that's the only thing I can use to learn the weather. But this is not really helpful. I see weather, I see that it says it's going to be 22 degrees Celsius. It doesn't mean much to me. What if I could feel, for a second, 2 degrees Celsius on my body, hook my body to the weather channel, feel what it is in New York, and then I know exactly what to wear. Because I feel it, and I go to New York, and I know exactly how it is. It's just a second. It's like the sensor exists. We know how the brain works. We know how the sensation works. We just create a sensation for a second. I feel 2 degrees Celsius, then I can know what to do. Or, for instance, why not go further? I hook my body to the stock exchange. If the stock exchange falls, I feel pain. And you say, oh, that's exactly means that my stock exchange. Or, you know, or to the wall. I leave my house. I crank my walls to my body, and if there's kind of a crank in my home, I feel a twitch in my hand, and I know that something I need to fix it quickly. Or if you want to go to a little kind of more science fiction thing, we can actually think of using a robotic arm. Right now you need 6 people to lift a piano, a grand piano. Why don't you get a robotic arm that's really massive, pick the piano with me, take it, put it somewhere else, just when I need it. I can hook it up when I need, control it from my brain, and move it back and forth. So these are thoughts for you to think of. I just want to make sure that you all know that I worked on this for many years with my former advisor at my PhD, Christoph Koch, who is a professor at Caltech, and the neurosurgeon Yitzhak Fried, who was the guy behind most of this work, including the implantation of the electrodes in the brain, and really pioneered this method that I hope will prove useful for many other patients. Thank you.